Welcome to I Love Apes. Today we're in Unit 2, Biodiversity, and we're going to look at natural disruptions to ecosystems. So here's the thing about humans. We've been very successful as a species because we disrupt our ecosystems, and we do that to give ourselves extra access to different resources that we need. But in doing so, we tend to make problems that are coming home after a while, like we're seeing now in the world today. And in order to better understand what to expect and how to avoid it, we can look at natural disruptions that happened in the past as a way of providing us with information about what to expect. So let's just take a look at this. So what we're looking at here is a climate graph. It's a little bit different from the climate graphs we looked at before. Still, the blue boxes here are going to represent precipitation. The temperatures are going to represent, the red lines rather, are going to represent temperature. But here's what's different. Instead of going from January to February over 1 year, we're going to look at thousands of years. So each of these represents 1,000 years. And so by doing this, what we're saying is, in this particular location that this climate graph represents, for thousands of years, in 17,000 years, the conditions stayed pretty much stable. And this does happen from time to time in Earth's past. And when this happens, this stability allows organisms a chance to evolve to better fill various niches. And because of that, what we find is specialist species tend to evolve, and they're very highly successful at very narrow niches. But it turns out nothing stays stable forever on this planet of ours. There are changes that occur, and we'll explain why later. But basically, if we take this same graph and say, well, what if after, like from between 17,000 and 9,000 years ago, things are stable, but all of a sudden something happened? We'll talk about what later, but basically what we find is that temperature dropped and the rate of precipitation dropped. Well, clearly that's going to affect this ecosystem these things evolved in. It's no longer the same ecosystem. There'll be different plant species living there, different animal species. And so what we find is we have these massive changes. It can even change the sea level. So things change a lot. And as a consequence, the organisms that evolve to be successful here, especially the specialists, when this happens, they tend to either go extinct, which is the usual thing, or maybe they migrate to, usually there's a little bit of time here to sort of follow the trend and stay with your biome and move north or south with it as the trends mandate. Or maybe if you have a slow enough change, you can adapt through evolution to fill new niches. But for the most part, you're just going to go extinct. Now, this is a good thing for us because basically about 2 million years ago, there was a cooling period on planet Earth, a massive ice age, and it changed where the biomes are distributed. And so these rascals used to be primates that primarily were tree dwellers in an African rainforest, or at least tropical seasonal forest. And as the climate changed, what was a forest became a grassland, and being in the trees was really not very good because there's no trees. So basically, these are an example of ones that they learned to evolve. Well, they didn't learn to evolve, they evolved. They had the fortune of evolving. And one thing they evolved was bipedalism. So bipedalism means standing upright on your feet, and it gives you a chance to look out over here. It frees up your hands to make tools and what have you. So this is what led eventually to you and me, Homo sapiens sapiens. But you can basically trace our evolution from other primates to who we are now as a result of this disruption to the global climate. So these natural disruptions that occur, they can occur at different levels. So you can have them occur at a localized level. So that would be like, say, a forest fire or a volcanic eruption or a tsunami. They affect a lot of area, but not the whole world, right? But then you can have these global level ones. So a global level disruption is something we definitely notice in the geologic record. And that would be things like an impactor, like you're getting hit by a comet or an asteroid, or some massive ice age that's going to change the distribution of where the biomes of Earth are, and that's going to cause a lot of changes in what species are alive and which ones go extinct. Now, the occurrence of natural disruptions, it can take place in either a periodic fashion, an episodic, or a random fashion. And they do ask you about this on the AP test, so let's make sure we understand the difference. So periodic basically means it happens fairly regularly, like on an annual or semi-annual basis. They definitely occur within a decade, let's just say. And then you have these episodic ones. So they're less frequent, but still repeating. We could talk like from decades to thousands of years time span. And then we have ones that are totally random. These ones can be quite sweeping in terms of the effect they've had on Earth's past, but they occur very rarely. And they occur hardly ever throughout geologic history, and there's just no pattern to their reoccurrence. They just happen when they happen, and fortunately, they don't happen very often. So let's start with periodic. So periodic means basically like annually or semi-annually. So let's look at a couple of these. One is the flooding of the Nile River. Now, the flooding of the Nile River, these people lived here for thousands of years, and these people kept meticulous records to the point that the 365-day year, it came from what are called Nilometers, where these priests would keep a watch for when the Nile began its annual flooding, because this brought nutrients and water to the farms and made life along the Nile possible. You look at the Nile on Google Earth, and you're just going to see just desert, lifeless desert, and this green strip where the Nile is. So they've kept a close eye on this for thousands of years, because it is a disruption that's going to happen every year. And then you have things like El Nino, which we'll study quite a bit this year. Now, El Nino happens basically every 5 to 7 years. So we know it's going to happen. We don't know when, but it's going to happen usually a couple times a decade at least. Episodic disruptions, though, these ones are less frequent, but they still happen quite regularly, but over longer periods of time. And the best example of this would be ice ages. So in this graph here, we see temperature, happens to be in Fahrenheit, I don't know why, but what we find is that when the temperatures get low, we have glacial periods, that means ice ages. And so we see these ice ages happen at a fairly regular interval. It's not completely regular, but every, 10,000, 20,000 years or so, you're going to get one. Random ones, they're just completely unpredictable, but they can cause things like these, impactors or large-scale volcanic activity events. So the largest disruptions that occur generally result in climate change, and climate change is by far the disruption that we're most interested in, because it tends to redistribute Earth's biomes, which causes species to go extinct, which leaves unfilled niches, so new species evolve. So keep in mind, these disruptions are part of Earth, but we don't really like it happening because of how it's going to affect us. So although the current climate change in Earth is a result of human activity for the most part, it's also important to know how it's happened in the past when we weren't the one causing it, because if we learn that, it can help us learn what to expect in the future. So Earth's climate has changed many times in the past, and so it helps to understand what can cause that. So let's jump into that. So basically, what can cause global climate change? Well, first is a variation in solar output. Another one is changes in ocean current patterns. And another one is changes in volcanic activity. Another one is the movement of the continent. So we're going to look at each of these in turn to see if we can gain some understanding of the factors here. Solar output. Generally, the sun puts out the same amount all the time, right? We talked about the solar constant earlier in Unit 1. We said, that's, it's 1,361 watts per square meter. But it turns out it doesn't always stay that way. And the best example we can find is what's called the Maunder minimum. So Galileo Galilei in the 1500s discovered sunspots, and people were fascinated by it, and they kept records of them. And what we find is there was a period here for about 150 years where there really wasn't much in the way of sunspot activity. And lo and behold, during that period, the world got colder. And there's lots of written evidence of these changes. So there's basically a mini ice age happened, glaciers advanced, and had this continued, it might have led to a global disruption of ecosystems. Fortunately, it did not quite get that far. It was fairly localized. Ocean currents is another one. Now, we'll talk about ocean currents a lot this year. Basically, ocean currents take warm water at the equator and they distribute that heat energy around the planet. Remember, warm water equals rising air equals rain. So the rain that we get in these different places is a result of these ocean currents. You change these currents, you change the climate in different places. And when you have climate change, you end up with lots of extinctions and other things associated with this disruption. Now, another thing that happens is volcanic activity. So volcanic activity is usually fairly stable. That you just, there's certain places that have eruptions, certain places don't. But there have been times in Earth's past, and in particular at the end of what's called the Permian, where suddenly the world revved up. All right, the Earth's internal heat got, it just produced a lot more lava. And what happened is, remember, when these volcanoes erupt, one of the things they release is carbon dioxide. Remember, we talked about the slow carbon cycle. And so they just dumped a lot of carbon dioxide in the atmosphere, and I mean a lot. And that caused a huge change. So 250 million years ago, in what's now Siberia, there was these massive fissure fields where it's just all this lava came to the surface, dumped all this carbon dioxide into the atmosphere. And as a result, climate change just took over, ran wild. The world got really hot. 90% of marine life went extinct, 70% of terrestrial. That's a lot. That's a major disruption there. It's the biggest extinction that's ever happened, and it happened because of climate change, because of carbon dioxide in the atmosphere. But in this case, it wasn't people driving cars and burning coal for electricity. It was just volcanic activity in Siberia. And the other one is movement of continents. All right, so continents move slowly, but they do move, and again, we'll study that later in this year. So basically, there was a time before Pangea, right, where we had these two areas. We had Laurasia and Eurasia, and we had this place in between called the Tethys Sea, and we had Gondwana land. And basically, you could have this equatorial flow of water this way, which left the rest of the continental edges fairly cold and dry. But then it closed. It got pushed close. And so what happened was this region here got very, very warm and wet. So we had a lot more precipitation here and a lot less over here. Point out too, yeah, ice ages can happen when a continent is pushed towards the pole. So you see during this time period here, during Pangea, Antarctica wasn't at the pole. But what happens is it got pushed down this way. And when it does, when you have land masses at the pole, it tends to accumulate massive thick sheets of glacial ice, continental glacial ice, and that definitely changes the climate of the planet in consequence. So let's look at what happens when these ice sheets form and grow and shrink. So basically, this is the world the way it looks today, showing the ice sheets that are currently located in Greenland and Antarctica, and we see the distribution of the current biomes on the planet. But if we could go in a time machine back 10,000 years ago, what we would find is the ice sheets were quite extensive. There was continental ice all over the world, especially in the northern hemisphere, right? All the way from Korea to Michigan to Finland to Germany. So there was ice sheets all over the place. And that had a big impact on the distribution of biomes. So if you look here, we have tundra, and right below tundra, we have this region of taiga forest, right? Conifer trees. Well, 10,000 years ago, that region was here. So we would have the taiga biome distributed here. And then as these melted, the taiga moved back north, and where they had been occupying North America, that part became mostly grasslands and temperate seasonal forests. So clearly that's going to have a major impact on the species living in that taiga biome, let's just say 10,000 years ago. Some of those species were able to migrate northwards with a moving biome. Other ones went extinct. That left empty niches, so other organisms evolved to fill them. The point being that any time we have these ice sheets growing and shrinking, we get changes in the distribution of biomes, and that makes a major disruption of life on Earth. Now let's just talk a little bit about what constitutes a continent. So most people would think that when you go to the beach, I love to go here. I love to go to, I grew up in this part of North Carolina. I love to go to in Rhode Island, North Carolina. It's a great beach. And when you're standing on that shoreline, you feel like, I'm looking out at the ocean. This must be the edge of the continent. But it turns out it's really not. The continent extends outward in this shallow area of ocean called the continental shelf. The margin of the continent actually isn't here where the current shoreline is, but out here where there's this steep drop-off called the continental slope. And this area here is all continental rock, similar to what you have here. So the continents extend outwards is my point. Now, so here you have my kind of lame drawing, trying to show you this. Okay, so here's our continent, here's our continental shelf, here's our continental slope, and here's our ocean water, okay? Now what happens is tectonic forces, which we'll study in a future unit, are going to move this continent closer to the pole. And when that happens, we're going to start forming continental glaciers. Basically what happens is snow falls in the winter and it never gets around to melting in the summer because it's not hot enough. And so you just get a deeper and deeper and deeper pile of ice, basically accumulated snow, called a continental glacier. Well, these things can be really thick. I'm talking about, like 3, 4, 5 kilometers thick. So you have quite a bit of this ice building up here. Well, where did it come from? Well, it came from the ocean. So basically, evaporation in the ocean got deposited here as snow in this continental area that's near the poles, and never got to return to the ocean. Well, let's just think about what some of the consequences of this is going to be. Well, that means sea level is going to have to drop, because ocean water that was here is now up here. And when the sea level drops, we end up exposing the continental shelf. And when you expose the continental shelf, well, you're going to have succession. And when you have succession, you will eventually end up with forests growing in what was underwater, under the sea, right? Before, like what if you go off from the coast of North Carolina right now, what's underwater is at one point was forests. Okay, so then what happens is, over time, you're going to get these periodic disruptions of, in this case, of climate change. The temperature of the Earth is going to change, and these continental glaciers are going to melt. And all the water that was here is going to return to the ocean, which is what we're seeing happening today. That's why sea level is rising. We'll talk about that later in the year. But what happens then is it's going to inundate the continental shelf. All the organisms that lived here, all the communities that lived here, they can't be there anymore because they're terrestrial, and now it's an aquatic ecosystem. And so you end up, again, like you can see, there's a major disruption that occurs when sea level rises, and it displaces all these organisms. And so we'll just finish off with this. So in addition to changing biomes and changing land areas, sometimes when this sea level drops, it forms what's called a land bridge. And 10,000 years ago, a land bridge formed between the Asian landmass and the North American landmass. And organisms were able to cross over. And one organism in particular was called Homo sapiens sapiens. And when humans arrived in North America, all the megafauna here, all the the woolly mammoth and the woolly rhinos and all these big protein sources, they had not evolved to be afraid of humans, and humans just made them go extinct like crazy 10,000 years ago. All right, so basically you have an introduced species gets into an ecosystem because of climate change, and it always leads to a massive disruption when you introduce a new species. Hey, thanks for watching. If you like this video, please go ahead and like this video. If there's something I do to make this better, or if there's another video you'd like me to make, please drop me a comment. You should probably check the description below, because I do sometimes post problems that could help you do better on your AP test. And of course, you know it's coming. Please hit that subscribe button for me.